All right, folks, so this is my best quick summary of what we did in class today. So problem A3 in comparing and scaling, problem 1.1, page 8. This is the data that is at the top of the page, and what you're asked is to determine whether or not all 4 of these statements are actually representing the same set of data or the same scenario. So since it's a comparison, when we try to address the first statement, the best we can do, because comparing requires at least 2 items here, is to just restate it. So we're going to make sure that we clearly understand what the first statement is trying to say to us. So we've got a taste test. People who preferred Bolda-Cola, so we know Bolda-Cola is going to be the larger number of votes, or the one that basically came out on top. Outnumbered, again, that's a comparison statement. So we have more of Bolda-Cola votes or preference than the other item. Preferred, outnumbered those who preferred Cola-Nola by a ratio of, and then these 2 numbers here. So what we need to do is we need to go ahead and write that out in some sort of organized fashion. So I'm going to go ahead and abbreviate Bolda-Cola and Cola-Nola, and then write out the number of votes. Now, this may or may not actually be the number of votes counted or preference checkbox, slips that are counted. It's just saying that there's a ratio of these 2 numbers. So we know that some variation of this ratio is reality for step 1. So let's see, we've got 17,139 here. That colon's going to make more sense as we start looking at ratios more and more. Just ignore the announcement. Sorry about that.
Quiet, please. The after-school club forms that were in your box are for those students who are interested in participating in the after-school clubs. Any students that do not want to do it, please don't hand out a form to those students. We are in the process of making more copies, but as of right now, we don't have enough to give out. So what we will do is just make a few more copies. Those students that don't want to participate, please give that form to students who would like to participate. Thank you.
So if we're going to see if number 2 if number 2 also represents this same set of information up here, the same data set, what we're going to do is first break it down. So the statement says that 5,713 more people preferred Bolda-Cola. 5,713 more than what, right? So there's only 2 numbers we're comparing, Cola-Nola and Bolda-Cola. So this must mean that 5,713 more people preferred Bolda-Cola over Cola-Nola, which means we now need to subtract the 2. So we need to find the difference between the 2 and see if this statement number 2, actually makes sense. So what happens when you stick that into your calculator what happens when you stick that in your calculator, you get 5,713. So looking at this says exactly 5,713 more people preferred Bolda-Cola. So this means these are actual vote counts now. We're getting more and more information about what's going on here. When we subtract those 2 numbers from statement 1, we actually get another way to represent that same set of data here in statement 2 by saying explicitly 5,713 people prefer Bolda-Cola. So now we know it's actually 17,000 people liked Bolda-Cola and 11,000 people and change liked Cola-Nola. So right now, statement 2 checks out. We did the math. We proved it. There's my mouse. We did the math, we proved it, we are good to go. Okay, so now we know these 2 statements representing the same data. So let's go ahead and look at number 3. In a taste test, 60% of the people preferred Bolda-Cola. Now we're getting thrown a whole new measurement, and that's a percentage. So here, it's important for number 3 that we understand what percents try to tell us. So percents is part per whole or parts per 100. Okay. In this case, we don't have exactly 100 votes. So we have to figure out what is the whole number of votes that we have for this particular taste test and what part are we concerned with. So the part that we're concerned with is the number of people that preferred Bold de Cola. So we look for Bold de Cola up here at the top. We see the number of people that preferred Bold de Cola is 17,139. So we know in this calculation which number to use. So since this 60% that we're looking for, so I'm trying to write with a mouse, so pardon the, second grade handwriting here. 60%, we're going to see if that equals the part that we have, 17,000. Let me go ahead and just type that. For Bold de Cola, so the part of the whole Bold de Cola votes. Now we need to know the whole number of votes. So the whole total amount of votes for Bold de Cola and Cola Nola combined. And the only way we find that is by actually doing the calculation. So I'm not going to show that here because I'm running out of space. But in your spiral, you should show 17,139 plus 11,426. And you should get 28,565. Now that we have the parts per whole, we can see if these number of parts divided by this number of total votes is going to give us 60%. And what happens when you go ahead and put this into your calculator, you get the value 0.6. Now the 6 is in the tenths place, so we know we can rewrite this fraction as 6/10. This is the tenths place, and we have 6 of them, therefore we can rewrite it as 6/10. And if we can rewrite that as 6/10, and we know that percents are parts per 100, we can scale this up by 10. 6 times 10 is 60. 10 times 10 is 100. We could have also recognized that putting a 0 here in our decimal, that this is 60 hundredths, because this is the hundredths place. However, we can show it this way as well. And since we know that 60 hundredths, parts per 100 represents percent, we know that 60 hundredths is 60%. So since each one of these equal signs is true, that means any piece is equal to any other piece. And if we take the number of parts from the first statement divided by the total by adding these two parts together, and we get 60%, that means statement number 3 is also true and represents our data. Now, the fourth one. In this fourth statement, a ratio, in this case, much like the first, is a comparison of two parts, not of parts per total. So here, they're using a ratio of 3:2. So I'm going to bring out my typing tool again. And this ratio that they're giving us is a ratio of Bold de Cola. I'm going to leave out the periods because it takes too long. Bold de Cola votes are 3 to every Cola Nola vote, which in this ratio is 2. So Bold de Cola outnumbered Cola Nola by a ratio of 3:2. We know the 3 belongs to Bold de Cola because Bold de Cola outnumbered or has a higher value than Cola Nola. So this is how we know what the order is. Now, if we're going to compare this to any of our other statements, it's going to be very difficult to compare this to these two values because I would have to figure out what to multiply 3 by to see if I get to 17,139 and what I multiply 2 by to get to 11,426, and that seems a little arduous, okay? Knowing the difference between the two isn't going to help me compare it to this statement. That's not helpful. However, if I look at this percent, if I can convert this to some sort of percent, I'm going to be in good shape, okay? So what I need to know from this ratio is parts per whole. I've got my parts. I know my Bold de Cola parts. That's 3. Now, what I don't have from this ratio is the whole. But I know since this part and this part equals the total number of votes, I just have to add them. So 3 votes for every 2 votes gives us a total of 5 votes, right? 5 votes total. If 3 of them are for Bolda-Cola and 2 of them are for Cola-Nola, that gives us this fraction of part per total of 3/5, okay? Now, I've got a couple options here. I can throw this in my calendar. That'll give me 0.6. Yep, I already know that 0.6 equals 60 hundredths and 60 hundredths equals 60%. I already know right now that I'm golden, but I'm going to show another way that we can do this. I want to see parts per 100 here. So I know I can multiply 5 times 20, and that will give me 100. So if I scaled up my denominator by a factor of 20, I need to scale up my numerator to have an equivalent fraction also by 20. So 3 times 20 gives me 60. And since I know parts per 100 equals percents, and I have 60 parts, I have 60%. And since this ratio can be converted to 60%, and 60% can be converted to this number of parts over this total number of votes, and these two numbers actually came from these two numbers, and this is also using these two numbers to come up with this value that they gave us in the problem. We have determined that every single one of these statements represents the same exact scenario. That's what we did in class today, and hopefully you as a student or you as a guardian can check and see if your student has this. Your students should have something similar to this. Each class found a little bit different ways to prove that everything was the same, but your students should have this work from today in their spiral under Classwork. If it's a big blank page, please have a conversation with your student. All of this was written on the board. We try to work together as a group to get all of this down. So this is what we did in class today for comparing and scaling, problem 1.1, A3, all 4 parts. Thank you very much for your time. I hope you found this video helpful.